that ranges from 321 to 384 feet tall, depending on mission requirements. This rocket will someday help NASA to reach its goal of human exploration of Mars.
Puppy.
Tower next to the VAB is the mobile launcher being built for SLS. When completed, it will carry a massive launch vehicle on top of the crawler transporter to pad 39B. You will learn more about the launch of SLS when we get to the launch pad. Adjacent to the VAB is the Launch Control Center, the distinctively shaped four-story building which houses the launch team. This is where the ground controllers, engineers, and launch director monitor the spacecraft and manage all the activities leading up to launch.
If you look on the left-hand side of the VAB, these two large gray doors that you see are called high bays, and that's where we stack and build the rockets. There are two more on the eastern side of the building. High bays 1 and 3 are over there. Number 3 is where we will build those SLS rockets. NASA wants to lease out one or more of the other high bays to the commercial space industry and allow them to build their spacecraft here. The building was initially designed to assemble 4 Saturn V rockets simultaneously. There are 70 different crane devices in there, so this is easily accomplished. Just to the left of the building, the 355-foot mobile launcher we're building for that rocket. Once it's completed, one of our crawlers will pick it up, take it in the VAB. We'll begin to assemble that rocket. It should occur sometime within the next year. Part sticking up in the air is called an umbilical tower. We're going to head out to the launch pads here. We'll give you a quick lesson in Rockets 101. These 3 cream-colored buildings you see here were the orbiter processing facilities. It's where we worked on and stored Atlantis, Discovery, and Endeavour. The 2 buildings closest to the road are being leased by the Air Force. They'll be refurbishing unmanned spacecraft in there. The 3rd building over, you'll notice, has a large mural. That's where Boeing is building their Starliner capsules for the commercial crew program. The tracked vehicles you see here are the crawler transporters. That's what we use to move the mobile launchers and the rockets around with. So to build a rocket, a crawler would drive underneath the platform. The short one here's from the shuttle. Pick it up and take it in the VAB. They'd assemble the rocket on board. Then the crawler would go back in, lift it up. It would begin its 6 to 8 hour journey out to the pad. If you look underneath the platform, you'll see there's 3 huge openings, 2 for the solid rocket boosters, 1 for the main engines, so that at liftoff we can vent the flames down into the flame trench and away from the pad, preventing damage to the spacecraft, platform, and the pad. The concept applies here with the mobile launcher for SLS. You'll see there's a huge opening here in the front for these main engines. The pads are, pad A is 3.5 miles away from the VAB, pad B is 4.2 miles away. Get a great view of the VAB. There are also large gray sliding doors on the north and south side of the building. It's called the transfer aisle. It runs the length of the building. It's as wide as an 8-lane highway. It's where the various parts of the spacecraft go in. Then they're sent to their high bays for stacking and assembly. Right next door, launch control is the brains of the operation here. 4 firing rooms in there. We used all 4 during the Apollo days, 2 for shuttle. They're updating one with state-of-the-art fiber updates for the SLS. Right next to us here is the crawler way. It's a specially engineered road more than 6 feet thick with many different layers of rock and composite to accommodate the tremendous weight of the crawler as it carries the mobile launcher and the rocket out to the pad.
We are now approaching Launch Pad 39A. It was constructed for the Apollo program and is where all 12 moonwalkers began their historic journeys. You'll learn more about the Apollo program when you get to the Apollo Saturn V Center. Following the end of the Apollo program, Pad 39A was the site that launched Skylab, the first U.S. space station to orbit the Earth, on May 14, 1973. Skylab provided America's initial experience with long-duration spaceflight. During 1973 and 1974, 3 Skylab crews were launched on missions of 28, 59, and 84 days. The first space shuttle mission was launched from here on April 12, 1981. Over a period of 30 years, there were a total of 135 shuttle missions. 82 lifted off from this launch pad. The reusable space shuttle system transformed the way we operate in space. The space shuttle launched dozens of communication satellites, as well as robotic spacecraft on groundbreaking missions to Venus, Jupiter, and Saturn. Not only did the shuttle deploy the Hubble Space Telescope in 1990, but it conducted 5 repair and upgrade missions that enabled the Hubble to literally rewrite astronomy textbooks. The Space Shuttle program ultimately assured its place in history with the complex, on-orbit assembly of the International Space Station, the ISS. The shuttle made 37 flights to construct the station, which is larger than an American football field and can be seen at night orbiting Earth with the naked eye. This unique scientific platform allows researchers from all over the world to work on innovative experiments and help to enable NASA's long-term human exploration plans.
As we make the turn here, if you look over to the right across the water, you'll see 3 sets of lightning towers. Those are the active launch complexes on the Cape side. Cape Canaveral is where the space program began, operated by the Air Force and Department of Defense. Over here at KSC, we're operated by NASA, a civilian government agency. This is where all the shuttles and the Saturn V's launched from. To the far right, it looks like a white rectangular building with lightning towers on either side. It's Complex 37. They launched Delta IV rockets from there. Right in the middle, you'll see 4 lightning towers. It's Complex 40. SpaceX launches Falcon 9s from there. Over to the left, you see 4 more lightning towers with a gantry in the middle there. That's Complex 41. They launched Atlas V rockets from there. Straight ahead here, Pad 39A with a single lightning tower coming off the top. Over to the far left, you see 3 lightning towers over there. That's Pad B. It used to be identical to Pad A. It's been reconfigured. It's what's known as the main pad, multi-purpose. It can accommodate any launch. So NASA didn't need Pad A here anymore. They put it out to bid. SpaceX won the bid for the second 20 years. They've modified the pad to launch 2 different rockets, a Falcon 9 and a Falcon Heavy Lift. So SpaceX actually has 2 operating launch pads right now, and from what we hear, they plan to sometime launch 2 rockets in one day. They have the capability of doing that, and they like to do things that other people haven't done before. They're the ones that perfected, well, almost perfected. They make it look pretty easy landing the first stage of their rocket stack. In the last 2 years, they built this horizontal integration facility. NASA, we build our rockets vertically. They build their rockets horizontally. If you follow the crawler way up the hill, you'll see they've installed a track system. The top of the tracks, the large white object you see up there, it kind of looks like a crane lying on its side. That's called a strong bag. That's the device they use to take the rocket from the building up to the top of the pad. It also takes it vertical for fueling and launch. It still looks a bit like it did from the shuttle program. The fixed service structure is still there. They did remove the rotating service structure. The back of the pad, the round white tank you see over there, held liquid hydrogen. On the other side of the pad's another one that held liquid oxygen, cryogenic fuel used for the main engines of the shuttle. to the right of the tank here, you'll see they've installed 4 new tanks. They hold RP1, that's a very highly refined kerosene. That's what SpaceX uses along with liquid oxygen in their Merlin engines. Over to the right, take a peek, you get a great view of Complex 41 right there. They just built that gantry and access arm. That's where Boeing will launch their Starliner capsules for the commercial crew program. They built that gantry and access arm to facilitate the astronauts getting into the spacecraft. Both Boeing and SpaceX have capsule test launches scheduled for this summer. Once those are complete, NASA will review the data and come up with a launch date, hopefully by the end of the year. They both obviously want to be the first companies to launch our astronauts from U.S. soil again. Now, some of the reasons why we launched from the east coast of Florida here. Number one, straight ahead, the Atlantic Ocean. It provides a great safety zone. The military sets up a perimeter out there to keep boating traffic out. As we drive around here today, you will see that most of the land here is swampland. It was inexpensive to acquire. Also, the Cape Side opened in the late 50s as a missile test range. It was kind of a natural progression. We're going to be able to stop up here briefly. There was a train crossing. It was used to bring in propellant during the Apollo days. But you'll get a great view and camera angle of the pad with the VAB in the background. Once the 2 buses in front of me stop and move over, I will pull up and put on the air brakes, the parking brake. So if anybody needs to move around to get a better picture, you're welcome to do so.
Claro, porque